when you first go to sleep, you go to sleep in stage one, and basically all that's happening in stage one is that you're losing a little sensory awareness. Obviously, all your sensory organs still work while you're asleep, but your brain quits paying attention to them, and that's because of GABA, which I'll cover more in a second. Um, but you start getting ready to go to sleep, and it's a little fuzzy, like you can hear stuff in the other room, or you can hear or taste or smell or feel or things, but it's the sensory is not quite the same. You realize you're not processing it quite the same. We all know that kind of half awake feeling. Then you go into stage two, which is proper sleep. But there's not a whole lot of hormonal triggers going on in that stage. It's more transitory. uh, so you start going down from stage two to stage three, which is the first level of deep sleep. Stage four, which is the deepest level of sleep. Sometimes that whole block is just called slow wave sleep, and sometimes that whole block is just called deep sleep, but it's all the same thing. And then that goes across time, and then you start crawling back up, and it's you go from four to three to two. Then instead of going back to one, you go up to REM, and then you do a REM cycle. And then once you come back down to stage two, we call that one sleep cycle. And the first sleep cycle is about 90% deep sleep, and then a tiny little bit of REM. And then the next sleep cycle is a little more REM and a little less deep. And then by the time you wake up in the morning, your last sleep cycle is like 90% REM and 10% deep sleep. And your cortisol is gradually creeping up. So, the first thing that happens, obviously we're all we are is a very complex organizations of trillions of little cells that are all doing the same thing, right? They're taking in oxygen, they're taking in resources, they're doing work, they're producing waste products. And so, we're just kind of a bigger version of that. And so, when we go to sleep, there's a bunch of waste products, and the biggest area that we need to clear is our brains, because our brain actually doesn't have a ton of blood supply, given how metabolically active it is. It's crazy that it can do what it does with as little blood supplies it has. Obviously, we have the cerebral spinal fluid, which is like providing resources for it, but also waste products are building up in there. And so when we first go to sleep, the astrocyte, the glial cells actually contract and create little cavities to flush more cerebral spinal fluid and get rid of waste products. Once the waste products are gone, that
And these are
starts triggering.
these waste products. Sorry to interrupt you, Doc, but these are like the byproducts of metabolism during the day.
Yeah,
These are the tau tangles, the beta
yeah,
amyloid plaques, and stuff that's sort of built up over having
yes,
the consequence of being awake. Let's say. Okay.
absolutely.
Okay.
And something that's obviously there's always anabolic and catabolic activity going on. Something sort of simplistic I tell to my clients is that being awake is catabolic and being asleep is anabolic, right? And so you're doing all of your anabolic activity, which means I'm taking small simple things and building big complex things out of them. So for as an example, I'm taking amino acids and I'm repairing my muscles, right? Or I'm using these hormones and cell signalers, and I'm rebuilding my muscle fibers that have been damaged, or I'm repairing my tendons or ligaments, whatever. Um, and then I'm also regulating my appetite hormones, right? So my leptin sensitivity, so the hormone that comes from my fat to tell my brain how much fat I have, and then that changes my fuel partitioning. Ghrelin, also orexin, that also gets balanced during deep sleep cycles. Growth hormone, testosterone, uh, estradiol comes from testosterone primarily, but DHEA, again, part of the precursors of both testosterone and estradiol. So all of my anabolic hormones, including thyroid, which is actually anabolic, um, all of my hormones, my insulin, all of that's being regulated during deep sleep. And I'm, like I said, I'm being really anabolic. I'm repairing things. I'm fighting off infections, and I'm trying to prepare for tomorrow, right? Well, I'm trying to repair and to prepare for tomorrow. And then when I go into uh, REM sleep, all like I've flushed out all the waste products, and I have metabolic and anabolic energy. I've uh, transformed a lot of my adenosine to ATP instead of just adenosine now. And I'm going to start that process that I talked about earlier. I'm going to start rehearsing things that I've learned and thought of during the day. I'm going to figure out if I want to hold on to that information or not, and if I'm going to make a durable pathway out of that or get rid of that pathway altogether. And so that happens every sleep cycle. Again, more and more REM, less and less deep. And so when you wake up in the morning, your metabolic set point. So one, obviously, we know cortisol is a stress hormone. The higher your cortisol is, the higher your appetite's going to be. Because the only time any animal on this planet sleep deprives itself, other than humans, is if it's being stalked, it's being preyed upon, or if it's starving to death. And if obviously, if it's being stalked, it needs to be awake to get away from whatever's stalking it. But if it's starving, it wants to be able to wake up earlier and forage further and get further and further away from the area with no food, and interferes with their impulse control, so they'll try novel foods. Just so we're the same thing, like our body perceives sleep deprivation as a stressor, and it almost certainly, I mean, you can't prove this, but evolutionarily it makes a lot of sense that our bodies would say, like our brains and body would say, oh, we must be being preyed upon, or we must be starving. And so when your body thinks it's starving, your appetite is pushed towards fat, right? And it's pushed towards the fastest glucose source you can possibly have. Fortunately for us now, we have high fructose corn syrup, which is like even more than sucrose. And so you're going to crave fatty foods. Your metabolic set point for like when you're full, so your hormones telling your brain that you're full, the sensitivity of that's changed. The sensitivity of leptin has changed. Your body believes that you're starving, so why not store everything that you eat that day as fat? Because that would be ideal, because use the bare minimum resources. We have cortisol pumping away to reduce all of our stored glycogen. So anything we can store as fat, let's store as fat, because that's going to protect us from famine. And then obviously you go far enough and ketones start assisting the brain and all of that other stuff. So there's absolutely nothing that you need during the day that isn't being balanced during the night. And so how much you eat, what you feel like eating, how alert you are, how much you feel like moving, what your strength is like, what your endurance is like, what your cognitive, problem solving, emotional skills, all of that is being set while you're asleep.